Hi everyone. Alright, so this video is for activity 8.2. This is where we're looking at 3 different groups based on how much sleep they got one night. They were randomly assigned to get 3, 6, or 9 hours of sleep. And we recorded the number of calories consumed by people in those groups. Okay. So we're going to run an ANOVA. Click on ANOVA menu and then select ANOVA. Our group is our independent variable. Factors are independent variables, so a group goes into the fixed factor box, and calories go into the dependent variable box. Before we look at the ANOVA output, you'll notice that it comes up there automatically. Let's start by looking at just descriptive statistics and graphs. If you click on descriptive plots, you can move group over onto the horizontal axis. And you can also look at error bars here. By default, it'll put confidence intervals on your graph, but you could also ask for the standard error if you prefer. And so it looks like here that group 3 consumed more calories than group 6, which seems to have consumed a little bit more than group 9. So what we need to know now is, are all these 3 means equal to each other? Right? That would be the null hypothesis, is that all 3 means are equal to each other. Or is at least one of those means different from the others? Okay. So first of all, before we start looking at the ANOVA output, let's look at the means and standard deviations as well. If you click on descriptive statistics, under the additional options, you'll see the means and standard deviations. The graphs are great, but when you report numbers, you often need to know the exact numbers, and you can get them there from the descriptives table. You can also get means and standard errors and confidence intervals from the marginal means menu by moving group over to that right-hand box. Okay. All right, so we're comparing these 3 means, and the overall ANOVA is up here at the top, testing the null hypothesis that really all 3 of them are equal to each other. So what we're looking at is our F ratio. Our F is 8.19. Right? And if the null is true, we would expect an F around 1. We expect a bigger than 1F if the null is not true. Right. So our p-value here is telling us the probability I would get an F of 8.19 or an even bigger F if in fact the null is true and there are no methodological flaws with my study. Right? So our p here is 0.00046, right? It's a very small p-value, which tells us that it's really unlikely that I would get an F of 8.19 or greater if the null is true and all of my means are actually equal to each other. Okay. So you can also, we can get an effect size here for this overall ANOVA by under additional options. You can click on estimates of effect size and click on omega squared. It'll give you eta squared as default, but we prefer to report omega squared. It's seen as a less biased estimate of the effect size. Right? So the overall F and omega squared give you a sense of the overall impact of sleep deprivation on caloric consumption. Right? But it's not that interesting. Right? What we're really interested in are those post hoc tests usually. So in this case, what we really want to know is, are any of those groups better or worse than others in terms of their caloric intake, or higher or lower? Okay. So in this case, we're looking now at, we have 3 groups. We got 3 hours of sleep, 6 hours of sleep, and 9 hours of sleep. And we want to make all possible pairwise comparisons. Right? So I want to compare group 3 to group 6, group 3 to group 9, and group 6 to group 9. To do that, I click on the post hoc test menu and move group over to that box on the right-hand side. And then asks for effect sizes, and I'm clicking on confidence intervals as well. And one thing that you do need to unclick is this Tukey correction. We're not going to take the Tukey correction. We're doing the Fisher LSD test as described in the book. So we're doing Fisher LSD rather than the Tukey. So unclick that or it'll confuse you when you look at your output. Okay, so we have our post hoc tests are in the post hoc output here. We're comparing group 3 to 6. You see we get a mean difference of 482 calories between those 2 groups. Group 3 to 9, we have a difference of 483. And we're comparing group 6 to 9, we get a difference of 101. Okay. So all it's doing to get these mean differences is taking the means here from the marginal means table or your descriptives table and subtracting them, right? So the difference between group 3 and group 6 is where you get the 482.325. Okay. All right, so for each pairwise comparison then, we have a t-statistic and an effect size. Okay. So for our t-statistic, the first one is 3.12. Okay, so we have a t of 3.12, and we don't have a p-value. Right? That's because JASP doesn't provide, at least currently, the p-value for the Fisher LSD test. Okay, so we're going to have to look up that value someplace else. So we're going to look up the t of 3.12 with 117 degrees of freedom. Those degrees of freedom come from this overall ANOVA summary table with the 117. Okay. So I'm going to go to the GraphPad calculator. You can find a number of these online. And I'm clicking on my t was 3.12 with 117 degrees of freedom. That gives me a p-value of 0.002. Okay. So you want to write that down because you're going to need it elsewhere later when you're doing your write-up. Okay, now our second t, right, is 3.79. So we have 3.79 as our next t, and the degrees of freedom is still 117. So I'm going to go back and change to 3.79. I get a p of 0.0002. Right? So the probability I'd get a t of 3.79 or greater or more extreme if in fact the null hypothesis is true is 0.0002. And then finally my last t is 0.66. And if I put 0.66 in my p-value calculator, my p, and I get 0.51. Okay, so make sure you write all those down. You're going to use them in your output later. Okay, so now the first t, 3.12, had a p of 0.002. That means that this difference between groups 3 and 6 is very unlikely to be due to sampling error. That difference is 482.32 is unlikely to be due to sampling error, and it's a large effect, 0.75. Okay. The difference between group 3 and 9 had a p of 0.0002, which was also very unlikely to be due to sampling error, and that's also a large effect. And then finally, the difference between 6 and 9 was only 101 calories with an effect size of 0.14, and we got a p-value that was 0.51, right? Which means it's pretty likely to be due to sampling error. Okay, so those are the values you're going to talk about in your output. I'm not going to walk through the output for this particular one because it's very similar to activity 8.1. Right? So when you're writing up your F, though, your overall F, the degrees of freedom are 2 and 117. The F is 8.19. Your P is 0.0004. And the omega squared is 0.11. Mean square error is mean square residual is at 474923.44. Okay. Your other values are coming from these tables. Use that model in 8.1 for your write-up. Okay. You should find it fairly similar in terms of how you're talking about it because it's the same basic layout there. But note that all of your post-hoc tests are not identical, right? So it's really important to notice that groups 3 and 6, there is an important difference there. It's a large difference. It's unlikely to be due to sampling error. Groups 3 and 9, also a large difference. It's unlikely to be due to sampling error. And in both of those cases, people who got only 3 hours of sleep ate quite a bit more than people who got 6 or 9 hours of sleep. Where 6 versus 9 didn't matter a whole lot. It was a small difference that was very likely to be due to sampling error. So make sure you explain that in your write-up. Okay? All right, then I'm signing off.